Hello, everyone, and welcome back to If It's Math. Today, we're going to continue our series on exponents as part of our Fundamentals of Algebra content. In our last video, we talked about positive and negative exponents and how you work with those. In this video, we're going to talk about the rules that are important to know so that you can start using exponents as part of evaluating and simplifying algebraic expressions. So we're going to cover a lot of rules today. So we'll do a ton of examples at the end to make sure that you can see how it all gets applied. So by the end of this video, you'll be able to apply the zero exponent rule, the product rule, the power rules, the quotient rule, and the fractions to negative powers rules of exponents. So that's a lot. But let's get started with a quick recap just to be sure we all remember what we're talking about when we're dealing with our exponents. So exponents, remember, are just a shorthand for how many times to multiply something by itself. So if you have x to the third, remember that that just represents x multiplied by itself 3 times. Oh, not the 3 at the end, but 3 times. So x to the third is x times x times x. And remember, though, that exponents only apply to what they touch. So negative 2 times x to the third is negative 2 times x times x times x. But negative 2x to the third is negative 2x times negative 2x times negative 2x. So you have to pay really close attention to what's inside or what's actually being affected by the exponent. And then the one other thing that's really important to remember is what happens with negative exponents. So if you had 3 to the negative second power, that just means 1 over 3 to the second power. So that gives you 1 over 9 in this case. So that's really what it is. Remember, you just multiply something by itself, however many times are indicated. You pay real close attention to what's actually being affected by the exponent. And then if you have a negative exponent, it just means flip it over. Okay, so let's jump right in because we got a lot of rules to cover. So up until now, we've talked about positive exponents and negative exponents, but not about what to do if the exponent is 0. And that's because it's not really clear. So there had to be kind of a rule defined for what we all are going to agree that this represents. So what we know is that x to the 0 power equals 1 for all numbers other than 0. So 0 to the 0 power, we have no idea what that means. So it's not even defined. So just remember that anything raised to the 0 power other than 0 is going to equal 1. So as you're working with expressions, we always just kind of make the assumption that it's not equal to 0 because that's the only time that that's not going to be the case. So if we think about a few examples of this, if you have 3 to the 0 power, guess what? It's 1. If you have y to the 0 power, is 1. And if you have, say, 3x to the 0 power, still 1. So as with any exponent, you have to be really careful with what it is and isn't touching. So if you have negative 3x to the 0 power, that's 1 because everything is being raised to the exponent. But if you have 3 times x to the 0 power, if you think about breaking it down, that's 3 times x to the 0 power, which is 3 times 1, which is 3. So again, you got to just pay really close attention to what's being raised to that exponent. So same thing here. Let's say we had negative 3 x to the 0 power. Well, that's negative 3 x to the 0, which is negative 3 times 1, which is negative 3. So you just have to pay really close attention to what's going on. Okay, so rule number 2 is the product rule. So what we're concerned about when we're looking at this is what happens if we're multiplying two numbers together with different exponents. So you got the same base, but different exponents. So what this rule tells us is that when you multiply a number raised to a power by the same number, that's a critical part, by the same number raised to another power, what you do is you put the number raised to the sum of the powers. So you have the same base, and then you add up the powers. So it makes a lot more sense when you actually are doing it. So if you have x to the fourth times x to the third, we've got the same base here. So you go ahead and do the base. And then the new exponent is going to be adding those two together. So x to the fourth times x to the third is x to the 4 plus 3, which is x to the seventh. So the general formula for this, if you're thinking about it, is that if you have x to the m power times x to the n power, that is going to equal x to m plus n. So that is the actual rule when we're thinking about the product rule. So let's do another example here. If we have y to the ninth times y to the 13th, that's going to be y to the 22nd. So you just add the 9 and the 3 together, 9 and 13 together. So the thing about this is that it does apply to both positive and negative exponents. So if you have x to the negative 3 times x to the negative 1, that's going to be x to the negative 3 plus negative 1, which will give you x to the negative 4. It also applies if you have a mix of positive and negative exponents. So if you have x to the fourth times x to the negative 2, that's going to be x to the 4 plus negative 2, which is going to be x to the 4 minus 2, which just gives you x squared. So one of the really important things about this rule is that it only applies if the base is the same. So if you have x to the third, y to the second, you can't simplify it beyond that because the bases are not the same. Okay, so now we're going to start talking about the power rules. There are multiple power rules. So the third exponent rule we're going to do is the actual power rules, and there are 3 power rules. So what this deals with is what if you have exponents raised to exponents is the first one. So the examples we were given before is say x to the fourth times x to the third. So again, we just added those together to get x to the seventh. But what if you have exponents raised to exponents? So let's write this out first before we get to what the actual rule is so you can see it a little better. So if you have 3 squared to the third power, you see how it's different, right? But exponents raised to exponents, it works the same way. So you just need to think about what that is. So that is going to give you 3 squared times 3 squared times 3 squared. So that is 3 times 3 times 3 times 3 times 3 times 3 again, right? Because I've got 3 squared, and 3 squared. So then when you collapse that back down, you just add them up, right? So I've got 1, 2, 3, 4, 5, 6 of them. So I know that this is going to be 3 to the 6th power. So if we want to think about what the rule actually tells us, it tells us that if you have x to the m power raised to the n power, that is the same thing as x raised to the m times n. Or just to make it a little bit easier to see, x raised to the m times n. So if you have x to the fourth to the third, that's going to be x to the 4 times 3, which is x to the 12th. So again, it's really important to keep this rule, this power rule, separate from the product rule. So if you think about, remember, product rule told us that x to the m times x to the n equals x to the m plus n. But when you're looking at this power rule, it's telling us that x to the m to the n equals x to the m times n. So that's the big difference there. So if you have x to the third times x to the fifth, that is x to the eighth. But if you have x to the third to the fifth, that is x to the 15th. Okay, the second power rule. What if you have a product raised to an exponent? So if that's the case, then you have the product of each number raised to that exponent. You can kind of break it down a little bit. So let's say you had 5 times 2 raised to the third power. Well, we know that that is the same as 5 times 2, 5 times 2, 5 times 2. We know from our old rules that we can group these however we need to. So that's 5 times 2 times 5 times 2 times 5 times 2, which is 5 times 5 times 5 times 2 times 2 times 2, which is 5 to the third times 2 to the third. So what this rule tells us is that you really, if you're multiplying two numbers and then raising to an exponent, you can split it apart. So the way to think about that rule is that if you have xy to the n, that is x to the n, y to the n. So let's look at an example real quick. If you had, let's say, 2x to the third, that is 2 to the third times x to the third. So that's going to give you 2 times 2 is 4, times 2 again is 8. So 8x to the third power. Okay, so what if we have a fraction raised to an exponent? So if you have that fraction raised to an exponent, what you end up is the fraction made at the numerator raised to the exponent and the denominator raised to the exponent. So you can just really split it apart, right? So if you have, let's say, 2/3 to the third, we know that that is 2/3 times 2/3 times 2/3. Then that will give you, if you do the first two together, that'll give you 4/9 times 2/3, which will give you 8/27. Well, if you think about 8/27, that's 2 to the third over 3 to the third. So it ends up being pretty similar to the rule we had before. You just break it out to make sure you can tell that it still works with fractions. That if you have x over y to the nth power, then that is x to the nth power over y to the nth power. So one example here again. If you have, say, 2x over y raised to the second power, or squared, we know that that is going to give you 2x squared over y squared, which will give you 4x squared over y squared. Okay, quotient rule. So what's happening here is, what if you are dividing numbers raised to powers? So the quotient rule relates to when you divide a number raised to a power by the same number raised to another power, the result is the number raised to the difference of the powers. So when we're dividing, we end up subtracting numbers. Or we're multiplying, we added them, so it kind of makes sense. If we're dividing, we're going to subtract them. So an example to think about here is, what if you had, let's say, 3 to the 6th divided by 3 squared. So what's going to happen is, you know that that is 3 times 3 times 3 times 3 with a couple more, divided by 3 times 3. Well, that 3 is going to cancel, that 3 is going to cancel, and the only thing that you're left with is 3 to the 4th. So that, as you can see, is 6 minus 2. So when you think about writing this in kind of rule format, what it tells you is that if you have x to the m divided by x to the n, then it's going to be x to the m minus n. So the order here matters. So the denominator exponent goes here, and the numerator exponent goes here, and the denominator exponent goes there. So let's take a look at an example. If we have x to the 7th divided by x to the 4th, that is going to be x to the 7 minus 4, which is x to the 3rd. And if you have x squared divided by x to the negative 6th, it looks kind of intimidating, but it doesn't matter if it's negative or not. It's going to be the same rule. You have x to the 2 minus negative 6, which is the same as x to the 2 plus 6, which is x to the 8th power. Okay, one more rule, then we're going to go through a bunch of examples. So this rule is fractions raised to negative exponents. So if you raise a fraction to a negative exponent, the result is the inverse of that fraction raised to the positive of the exponent. That makes absolutely no sense without seeing an example. So let's look at this in actual numbers. So if you had 2/3 raised to the negative second power, right? We know from our previous rule that this is going to be 2 to the negative second power divided by 3 to the negative second power. Remember, what you can do is flip them, right? So this is 2 to the negative second times 1 over 3 to the negative second. And then if you continue from what we learned before, this 2 to the negative second is going to be 1 over 2 squared, and this 1 over 3 to the negative second is actually going to end up giving you 3 squared. So you put it together, you get 3 squared over 2 squared, which is 3 halves squared. So here's where you can see the relationship, right? So it's raised to a negative. So you take the 2/3, turn it into a 3 halves, which lets you take the -2 and turn it into a +2. So when you think about that written in rule form, what that's going to tell you is that x over y to the negative to the negative n, I can write it in, that'd be helpful. X over y to the negative n is y over x to the nth power. And that's the rule. So if you had to actually solve one, let's say that you had 5/4 to the -3rd power. Well, we know from the rule that that's going to be 4/5 to the 3rd power. So that gets us back into positive exponent territory. Once we're there, remember we're going to use our other rule, which says that that's going to be 4 to the 3rd divided by 5 to the 3rd. So that's going to be 16 times 4 divided by 25 times 5. And that gives you 16 times 4 is going to give you 64. 25 times 5 is going to give you 125. So again, just to walk you through it, you have 5/4 raised to the -3. So you flip it around, get 4/5 raised to the +3. Then you raise each number separately to the 3rd, and then just work out the math to get down to 64 over 125. Okay, so let's practice because that's some complex rules, and you end up having to do them all put together very frequently. So I'm just going to go through a bunch of examples. I'm not going to name the rules, but as we go through it, we'll just work together on it. So if you have -6x to the 0 power, this is one where you got to pay really close attention to what is raised to the exponent. So this is -6 times x to the 0. That's how you need to think about it. So that's -6 times 1, because we know that anything raised to the 0 power other than 0 is 1. So that's -6. If you had 356x to the 0, it's just 1, because everything there is raised to the 0. Then if you have x squared times x to the 4th, that's going to be x to the 2 plus 4, because those things are multiplied. It's going to give you x to the 6th. If you had x to the 3rd times x to the -5th, that's going to give you x to the 3 plus -5. It's going to give you x to the 3 minus 5. Gives you x to the -2. If you have x to the 3rd times y to the 2nd, it's kind of a trick question because you can't do anything with it. Just x to the 3rd, y to the 2nd, because the bases aren't the same. So you can't add those exponents unless the bases are the same. So since we have an x here, but a y here, you cannot add those exponents. You just got to leave them be. So what if we have y to the 4th to the 6th? So remember, when you have exponents raised to exponents, you have to multiply. So this is y to the 4 times 6. That's going to be y to the 24th. If you had x to the -2nd, say all that raised to the 5th, still the same. You got to have x negative 2 times 5. That's going to give you x to the negative 10. So what if you have xy to the fourth? Remember, if you have two things multiplied together raised to a power, you can split them apart. So that's going to give you x to the fourth, y to the fourth. If you had, say, negative 4x squared, then that's going to give you negative 4 squared times x squared. So that would give you 16x squared. If you have 3/4 squared, remember what you can do when you have fraction raised to a power is just break it up. So 3 squared over 4 squared, you'll get 9 over 16. If you had 2 over x raised to the third, you would get 2 to the third over x to the third. So 2 times 2 is 4 times 2 is 8. So you have 8 over x to the third. If you have x to the fifth divided by x to the third, when you're dividing, you subtract these. So you'd have x to the 5 minus 3, which would leave you with x squared. If you had y to the third divided by y to the fourth, same thing, you subtract them out. So you have y raised to the 3 minus 4. So y to the minus 1. If you had 2/3 raised to the negative third power, remember the first step is to flip the fraction and raise it to a positive power. Then you can break it apart to 3 to the third over 2 to the third. 3 times 3 is 9, times 3 again is going to give you 27. 2 times 2 is 4, times 2 again is going to give you 8. So that'll be 27/8. Then if you had y over x to the negative second power, again, you're going to flip it, x over y to the positive second power, gives you x squared over y squared. So that was a whole lot. Please feel free to go back, rewind, rewatch to help with getting through those examples and all the rules that sort of applied there. So let's just do a quick recap and writing it out in rule format to do kind of like a study page here. The zero exponent rule, remember what that tells you is that x to the 0 power equals 1, unless x is 0. So that's that rule. The product rule, remember, told you that x to the m times x to the n equals x to the m plus n. The power rule 1 told you that x to the m to the n is x to the m n. So you multiply them in that case. Power rule 2 told you that x, y to the n is x to the n, y to the n. That power rule 3 told you that x over y to the n equals x to the n over y to the n. I didn't leave myself enough room, but if you're looking at the quotient rule, remember that quotient rule, we'll go over here and do this one. It's going to tell you that x to the m divided by x to the n is x to the m minus n. Then if you're dealing with fractions to negative powers, remember that was telling you that x over y to the negative n is the same as y over x to the positive n. So these tell you zero exponent rule. Anything raised to a zero power is 1, unless it's 0. Product rule tells you if you have x to the m times x to the n, you add the exponents together. So x to the m plus n. Power rule 1, if you have exponents raised to exponents, you multiply them. So x to the m to the n is x to the m times n. Power rule 2, if you have two numbers multiplied together raised to an exponent, so xy to the n, you can split it apart and do x to the n times y to the n. That's how you end up there. That power rule 3, dealing with fractions, tells you if you have a whole fraction raised to an exponent, you can just kind of distribute that n is the way to think about it. So x to the n over y to the n. Quotient rule is that two exponents divided means you're going to subtract it out to get the final exponent. And if you raise a fraction to a negative power, you flip over the fraction and make it the positive of that power. So that was a whole lot. Give yourself a pat on the back for making it through all that. That really is, though, all there is to exponent rules. Again, feel free to go back, rewatch if you need to refresh on it some. I do hope this video was helpful for you. Please like it if it was, and subscribe to our channel to be the first to know about new content. And always remember that if it's math, we have the solution.